Entropy-as-a-Service, our offering in that space really stems from this effort and this concept that emanates from NIST. The idea there is, after having recognized the fact that there is a serious problem with today's systems and their inability to obtain good entropy, what NIST decided to do in 2012, they embarked on a notion of building, think of it as an ecosystem of entropy servers, and you could parallel that to the notion of network time protocol. So I'll make a quick parallel. Today, if you want to synchronize the clock of your computers, your cell phones, your alarm clocks, your TV, you can point these devices to a network server somewhere on the planet. If you're a Canadian, there are Canadian websites you can go to. In the US, it would be NIST. In Germany, it's a different one, and so on. These are global community of network time protocol servers, and anybody can actually access the time and have an accurate to within a very good accuracy. If you are using or deploying application servers in a data center where you need a slightly more precise time in each of your machines, you would likely have built in your data center network time protocol servers locally, not depend on the national level ones. If you're a telco and you're trying to do your billing, you want to have every one of your billing sites to have the same time, chances are you will have deployed your own infrastructure inside your own networks. Network time protocol has evolved to have the concept of it's an ecosystem. Everybody uses the same protocol. You can get time from the national source or your telco or your data centers or your local machines. And it's all the same idea, and any systems we use today, be it a small watch or anything fancy, can get time because they all use a standard. What NIST is trying to promote with Entropy-as-a-Service is a similar kind of idea. They're trying to do the exact same thing, have a global network of countries and large institutions like NIST to provide that overall service to their constituents. It could be, if I'm an American, I want to point my entropy request to a NIST server. If I'm in Canada, I might want to point to the Canadian Entropy-as-a-Service server. In essence, they want to try and make a global community of Entropy-as-a-Service beacons to provide that capability. Once you have that at the national level, then it just makes sense to have the same capability deployable into your telcos, into your data centers, your clouds, public ones, hybrid ones, private ones, your own data centers, your local stores. You can have entropy everywhere. And the design that NIST is proposing and promoting is one that really is about standards that are globally acceptable. They are not saying one bit that they absolutely want everybody in the world to go to NIST. They're saying, let's build a communication standard, a capability for any device, an IoT device, a web server, a cloud application, to reach out and fetch solid entropy result. In fact, they go further. They suggest that you should actually go and fetch different entropy buckets from as many sources as you can find. So go to the NIST one, go to the Canadian one, go to the Japanese, go to the Korean, go wherever you want to go and build up more entropy. You can never have enough entropy as far as cryptography is concerned. So build as many of those queries as you want, and once you've received or you feel you've achieved a sufficient level, mix it and build up your own random numbers. So that's the idea. So I think it's an excellent idea. It will become, in our view, a fundamental building block of the internet of the future, where you'll have to have communication capability, you'll have to have good power, you'll have to have a good source of time, and you'll now have to have a good source of entropy. Those will be fundamental building bits and pieces Then you can build anything. But you need that as your foundations, otherwise you miss a big part.